Welcome to this video on interpreting the coefficient of determination. Let's begin. After watching this video, you will be able to interpret the coefficient of determination. Finding the coefficient of determination. It is possible to calculate the value of the coefficient of determination r squared by hand. However, performing this calculation manually is very time-consuming and impractical. As a result, in this course, you will be using technology to calculate the coefficient of determination r squared. You may need to watch a separate video depending on which statistical software you are using in order to learn how to use that statistical software package to find the coefficient of determination. Interpreting the coefficient of determination. The coefficient of determination, r squared, tells us what percent of the variation in the response variable can be explained by the variation in the predictor variable. For example, suppose that we find our coefficient of determination, r squared, is 0.75. This means that 75% of the variation in the response variable can be explained by the variation in the predictor variable. The remaining 25% of variation in the response variable is explained by other factors. When you interpret your coefficient of determination, make sure that you state what the response and predictor variables are in your particular problem. Let's take the example of blood alcohol content versus number of beers. How much alcohol can one consume before one's blood alcohol content, or BAC, is above the legal limit? To answer this question, an undergraduate statistics project was conducted at the Ohio State University in Columbus, Ohio, that explored the relationship between blood alcohol content and other factors, such as the amount of alcohol consumed. Each individual participating in the study was assigned a random number of beers they had to drink. The blood alcohol content of the individuals was then measured at 2 different time periods. So you can use different statistical software packages to create a linear regression in, again, whatever software you have. So regardless of what software you use, you're going to get an output that looks like one of these things. Okay? So then in this output, they give you a lot of information. So you need to go through and find, well, where is my coefficient of determination? Where is my r squared value? So as you can see, in the first output, it is there. In the second output, it's right here. So these are the coefficient of determination. Okay. You can also see that there are a lot of digits after the decimal point, right? So we probably don't necessarily need to recreate or reproduce all of those digits when we give our answer. So you're probably going to need to round your value. In general, you want to either follow the directions. If the directions say round to 3 or 4 decimal places, that's what you should do. In this case, I would like to round to 2 decimal places, or the nearest 100th. So I am going to round our r squared value to 0.80. So let's interpret an r squared value, or a coefficient of determination, of 0.80. Okay? So what does this tell us? This tells us that about 80% of the variation in a person's blood alcohol content can be explained by the variation in the number of beers they consume. Again, this is assuming, right? This is saying that the number of beers is the predictor variable, right? Because that's the thing that you can directly control and influence. And the response variable is the blood alcohol content. So that means that the remaining 20% of the variation in blood alcohol content can be explained by other factors. Now that you've watched this video, you should be able to interpret the coefficient of determination.